Okay, so let's put this graph on the page. Just a quick heads up, in between starting this and doing the last one, I found one small error in my work, which probably as you were watching, you were yelling out to me, begging for me, please don't stop the video until you make this correction. And so that's down here for our last point. This should have been, of course, 16 minus 9 on the bottom. That's a positive 7. I had marked it as a negative 7, which means, well, negative 8 over positive 7 would be negative 8 over 7. We said, right, this should have the opposite sign as the numbers up here. So in our table, this should be a negative 8/7 versus the positive 8/7 up here. So it's correct on the notes. It'll be correct when I scan it. Just one small error at the very end of that last video. So if we take that, if we start to sort of work off that table and start to like plot those points individually, maybe we'll plot our points first and then we'll put our asymptotes in and then we'll try to put all that together. So I've got 0, 0 marked. I've got positive 1 and positive 1/4 marked. We said we didn't do anything for 2. We don't necessarily need it. 3 is our asymptote, so out to positive 4 is where we get this negative 1 and 1/7. So negative 1 is here. 1/7 is, I don't know, ballpark-ish here. We're not trying to draw the most perfect graph that ever existed. I rescaled the y-axis a little bit, just anticipating that we were working with some fractions in the y values. So this is sort of 1/2 for every block on our y values, and it's just 1 for 1 on the x-axis. We have then, because this is this sort of origin symmetry, we have similar values if we go to our negative numbers, but we get slightly different points, right? So negative 1 goes down to negative 1/4. So we have a little bit of a mirroring thing happening here. Again, this is sort of this origin symmetry, and in theory we should get a positive version of this. If we go back to negative 4, which we did, negative 4 was at 1 and 1/7. It was positive. So that's kind of roughly up there. Before we can fill all this stuff in, we need our asymptotes, of course. So we had 2 vertical asymptotes at positive and negative 3. So that's going to be here. And then the negative 3, right, is going to be here. And then we have a horizontal asymptote right at y equals 0, right? So that's right on the x-axis. I'll mark it here. I don't know how well it's going to show up, honestly. If I put these sort of green dotted line, it just kind of makes it look a little mushy. Honestly, it's sort of tough to visualize that just with pens and stuff. So in any event, we need to make sure as we get further and further out to the edges that we come down towards y equals 0. We're going to come down towards the x-axis. So if we try to sort of draw lines that fill in all this information, what are they going to look like? So we're not going to cross the axis anywhere except here at 0. Otherwise, if we have, for example, like we have here, a positive value, we're sort of only, the only thing we can go off of is the asymptote information. So we have the vertical one here, so this is going to have to sort of go and push up. It can't come across and push down because you'd cross the axis again, which again we sort of said is not possible. Our horizontal axis is going to be going towards 0, so we're going to sort of draw this and we'll level it off. Just in the keeping with the idea of this, like the symmetry of the function, maybe let's do the same kind of movements, but over here on the positive side, we'll try to sort of match that same behavior, right? So towards y equals 0 as we go out to the right, and then coming towards positive 3, we're sort of pushed, in this case, down to negative infinity, right? So now we're down in the negative half of our y values. In the middle, so what's happening? Well, we know we got to go through 0, 0. In this -1, we're in the negatives. So what that must mean is that as this curve goes towards -3, it gets pushed down. It's got to get pushed down. It can't turn and go up and meet this one because it's not able to cross the axis again. We didn't have another x-intercept. If we sort of keep that going, obviously we're going to go right through the center, and then we're sort of forced to go up. We sort of have this sort of mirror image. So there's kind of a positive up here that's sort of matched by the negative here. We have this sort of negative corner matched by this positive corner. So it's symmetric to the origin. It has this kind of a diagonal symmetry, where if I sort of flip the signs on the x values, I sort of also flip the signs on the y values. And that's what we've got. That's the end. That's our graph. -2x over x squared minus 9. And that's a wrap on 3.5.